Okay, so let's go further on subtopic 3.2, which is about Nernst equation. Okay, before we proceed in learning more about Nernst equation, I want you to know, kita belajar pasal Nernst equation ni mainly because you want to find the non-standard cell potential. So, apa beza standard dengan non-standard cell potential? Okay, previously dekat subtopic 3.1, you belajar standard cell potential ada bulat kan ke atas tu because it happens at a standard condition. But what happen kalau let's say dia berada bukan pada standard condition, dia tak adalah bulat ke atas ni, dia jadi cell potential je. And also cell potential is also known as EMF, cell voltage. Okay, so basically kita boleh calculate cell potential by using the Nernst equation. Okay, kegunaan Nernst equation ni ialah to calculate the non-standard cell potential yang dikenali sebagai EMF juga. Okay, so this is the Nernst equation di mana Ecell is equals to E naught cell minus RT over NF log Q. Okay, di mana R ni ialah gas constant 8.31 joules per Kelvin per mole. T ialah temperature and it must be in Kelvin unit. F ialah Faraday constant. Ni diberilah dekat dalam kamu punya kertas exam paper. N adalah the number of electron that is transferred ataupun balance number electron. Q ialah reaction quotient. Okay, this one is not something yang you tak familiar. You have met this before dekat chapter 6 semester 1. Okay, but dia ada a little bit twist kat sini because kalau let's say chapter 6 tu kamu ada QC, ada QP, di mana Q ialah reaction quotient in terms of concentration, QP ialah reaction quotient in terms of partial pressure. But in Nernst equation, somehow there will be a question yang kamu boleh gabungkan partial pressure and concentration in one reaction quotient ni, okay? So stay tuned. Okay, so there are a few factors that affect the cell potential. Okay, this is not that important as how you boleh memorize the Nernst equation and find the value of Ecell. Okay, ni additional info je. So basically the value of Ecell or dikenali sebagai EMF ni, it depends on the concentration of the ions in the cell. Okay, kalau you tengok dekat this Nernst equation, you can see the log concentration of product bahagikan dengan the log concentration of reactant kan. And supposedly kalau tak ada log ni, the relationships between Ecell dengan product adalah directly proportional. The relationships between Ecell dengan reactant ialah indirectly proportional, tapi sebab ada log kat sini dia jadi terbalik. Therefore, bila kita naikkan concentration of the reactant, the value of Ecell pun akan increase. Okay, because ada log kat sini, somehow diorang punya relationships are directly proportional. Kalau let's say nak compare dengan concentration of product pula, if let's say you decreasekan concentration of product, the value of Ecell will be increased because ada log kat sini, somehow the relationships between the concentration of product and also Ecell is indirectly proportional. Next is the temperature of the solutions. Okay, their relationships are directly proportional because if you increase the concentration of temperature, the value of Ecell will be increased. Okay, so basically their relationships are directly proportional. Alright, and lastly, the types of the half cell. If let's say the half cell with more negative SRP value, kamu letak dekat anode, therefore dia akan increase the value of Ecell. And also if half cell with more positive SRP value, you letak dekat cathode, also it will increase the value of the Ecell. Okay, selain kegunaan Nernst equation untuk mencari the value of Ecell, also it can be used to find the concentration of partial pressure ataupun concentration of species melalui reaction quotient. Okay, tapi kat sini dengan syarat semua value of Ecell, Ecell ni mestilah diberi dahululah. And then next is, selain daripada itu, Nernst equation juga boleh digunakan untuk calculate the equilibrium constant, where at equilibrium Ecell ni akan jadi 0. Okay, this one nanti we will go through this later, alright? Okay, so let's look at example 1. Dia bagi tahu kat sini ada sebuah sel ni ada dua different half cell reactions with respective SRP value. How do you know that this is SRP value with respect to each of these half cell reactions? Is because this E bulat kat atas ni dia tak tulis pun ada sel kat bawah. So you tahu this is the symbol untuk SRP value. Okay. Lepas tu dia bagi tahu calculate the cell potential. Calculate the cell potential. Cell potential tadi kita dah belajar cell potential, dia punya simbol dia ialah Ecell, di mana Ecell ni ialah non-spontaneous cell potential. Okay. Kalau non-spontaneous cell potential, macam mana kita nak cari? Kita boleh cari dengan menggunakan Nernst equation. Okay, that's why you have to hafal Nernst equation tersebut. And then dia bagi another additional info here. The concentration of Ni2 plus ialah 1 times 10 to the power of negative 4 molar, and concentration of Cr3 plus ialah 2 times 10 to the power of negative 3 molar. Okay. How can we solve this question? Okay, basically, to calculate the non-standard cell potential, you need to memorize the Nernst equation. So, this is the Nernst equation that we have discussed earlier. Okay, sekarang ni macam mana kita nak cari E0 cell? E0 cell ni ialah standard cell potential. Okay, how can we find this out? We can find this out through this equation that we have learned in subtopic 3.1, di mana standard cell potential is equals to half cell potential standard at cathode minus dengan half cell potential standard at anode. Okay. Macam mana kita nak cari the one yang berada di cathode dengan anode? You look at the SRP value. As usual, the higher the SRP value, the higher the tendency the half cell reactions to be at the cathode. So, tengok siapa yang ada higher SRP value. Yang lagi more positive SRP value ialah Ni2+. Okay, so basically Ni2+ ni dia more positive. Since that dia more positive, so dia akan berada di cathode. Okay. Kalau yang this one akan berada di anode. Okay, senang je, macam tu je. Okay, so we have decided the one yang ada higher SRP value yang towards positive will be at the cathode, and sebaliknya will be at the anode. Okay, so sekarang ni what you can do to find the non-standard cell potential by using the Nernst equation, you need to find the standard cell potential first. Okay, so how can you do it? First thing first, you need to build this half cell reaction of anode, cathode, and the overall cell reaction. Lepas tu kita boleh cari the standard cell potential by using the formula E naught cathode minus E naught anode. Okay, so sekarang ni you build the half cell reaction equation yang berada di cathode, di mana Ni2+ ni dia akan undergoes reduction, so dia akan gain electron. Pada asalnya this is dia punya equation yang asal. Okay, and then we don't need to change anything pun, but the one yang berada di anode adalah we have decided Cr chromium ni kan. Okay, tapi kalau the ones yang berada di anode dia akan undergoes oxidation, so dia kena lose electron. So what can you do here is you can flip this equation, the half cell reaction equation. So dia akan jadi Cr solid, and you will get Cr3+ plus dengan 3 electron. Ini adalah equation yang asal, tapi I'm sorry that I already cut it short. So I just sebab nak balancekan dia punya number of electrons supaya senang nak cancel out with each other. Sebenarnya pada asalnya this is the number of electrons respectively to each of these species. Okay, So, after you dah buat the correct half cell reaction equations yang berada di anode dengan cathode, okay, SRP value tak payah tukar pun, because basically kalau you nak guna formula E naught cell is equals to E naught cathode minus E naught anode, you don't have to change anything about the SRP value, so you can just take what apa yang dah dibagi. And then next, after you have balanced out dia punya the number of electrons, okay, sebab ini 2 dia 3, so ini kena kalikan dengan 2, okay, and then and this one kena kalikan dengan 3, so that's why lah dia ada stoichiometric coefficient yang baru kat sini, okay. And after we can cancel out the 6 electrons here, and you will get this overall cell reaction equations. So how can you find the standard cell potential? By using this formula, and you masukkan saja and you will get your answer. And next, you refer dekat you punya Nernst equation. What else do you need? So sekarang ni kita dah jumpa the value of the standard cell potential. Now you will have to find the value of N and also the reaction quotient. Okay, so how can you find the value of N? You look at your balance number of electrons here, which is 6. Okay, sebab itulah pentingnya untuk kamu buat betul-betul half cell reaction equation yang berada di anode cathode, balancekan the number of electron before you cancel it out, and after that baru you dapat overall cell reaction. Okay, sebab tu penting lah untuk you cari benda ni, tulis elok-elok. Sebabnya bila once you have got your overall cell reaction, you boleh build you punya reaction quotient. You kena ingat reaction quotient ni fasa yang dia perlukan ialah fasa apa? Gas ataupun aqueous, okay? And also reaction quotient ni it depends on the concentration ataupun partial pressure yang berada di bahagian produk to the power product, bagikan dengan partial pressure ataupun concentration yang berada di bahagian reactant to the power of reactant. So it's very important for you to build this reaction quotient by referring it to the overall cell reaction, okay. So basically to find Q, you have to relate it with the overall cell reaction equation. Satu you kena buat elok-elok supaya you boleh nampak kat sini. Okay, yang berada di bahagian produk ialah 2Cl3 plus aqueous dengan 3Ni solid. As you can see, this is a pure solid, so pure solid you tak boleh letak dalam reaction equation. Okay, sama dekat this is bahagian product and this is bahagian reactant. Okay, kat bahagian reactant ni you can see ada satu pure solid yang you tak boleh masukkan dalam reaction quotient. Therefore, when you want to build the reaction quotient here, you can see Cl3 plus ni dalam aqueous phase, so therefore it's going to be concentration of Cl3 plus to the power of stoichiometric coefficient Cl3 plus, which is 2, divided by concentration of Ni2 plus, since that it is in the aqueous phase, to the power of stoichiometric coefficient of Ni2 plus, which is 3. Okay, dia ada bagi tak concentration of Cl3 plus dengan Ni2 plus? Of course dah bagi previously. Dekat soalan dah diberi the concentration of Cl3 plus dengan Ni2 plus. So, what else do you need? You just need to substitute everything else because you have found N, you dah tahu nak build Q. So, you masukkan saja all of these things and lastly, you will get your non-standard cell potential. Okay? Alright, so for the next question, disuruh kamu calculate the cell potential. Again, kalau dia tak mention standard, that means it's a non-standard cell potential. Therefore, you have to find it through the Nernst equation. Okay, so kat sini dia bagi kamu cell notation. So kalau let's say you ingat balik cell notation, apa yang berada di depan ialah apa yang berada di anode. Okay, and this is the bridge, and this is apa yang berlaku di cathode. Okay, you remember A, B, C, anode, bridge, cathode. Okay, so kiranya the one yang undergoes oxidation ialah zinc. So, apakah half cell reaction of zinc bila dia undergoes oxidation. This is how it looks like, and this is the SRP value untuk zinc, okay, which is negative 0.76. Manakala yang akan undergoes reduction dan berada di cathode adalah copper. Okay, so this is the half cell reaction of copper bila dia undergoes reduction. Okay, di mana copper 2 pluskan 2 elektron, and then dia akan dapat copper solid. And this is the SRP value for copper, which is negative 0.34 volt. How can you get this? Is from the SRP table. Tak pun kadang dalam exam dia dah bagi siap-siap SRP value untuk copper and zinc respectively. Okay, so sekarang ni, as what I told you, you need to find the overall cell reaction first, lepas tu baru you calculate your standard cell potential. Okay, so this is the overall cell reaction, di mana kat sini you have balance dia punya number of electrons supaya dia boleh cancel out each other, which is 2 lah. Dia punya n, the number of the balance electron, n is equals to 2. Okay, tapi to find the standard cell potential, we have to use this formula, E naught cathode minus E naught anode, and you will get this value as your standard cell potential. And refer balik kepada your Nernst equation, you know that you need to find the n. N adalah the number of valence electron, which is the balance electron here ialah 2. Okay, and then how about Q? Q ni you kena refer dekat overall cell reaction. Okay, kat sini produk dia ada copper solid. This one we don't need this dekat Q, and also we don't need this as your Q, as your reaction quotient. So when you build your reaction quotient, this is what you get, which is Q is equals to concentration of the product Zn2 plus bahagikan dengan concentration of reactant Cu2 plus. Okay, lepas tu macam mana nak tahu masing-masing ni punya molarity? You boleh refer dekat this cell notation, di mana copper ni molarity dia 0.4, zinc 2 plus molarity dia ialah 0.02 molar. Okay, so you masukkan saja, and lastly you will get your cell potential ialah positive 1.14 volt. Okay. Alright, so let's look at this example. This example is quite unique because nanti reaction quotient kamu nanti unique sikit. So basically galvanic cell ni dia ada zinc and also SHA, standard hydrogen electrode. Okay, and then dia bagi info concentration of zinc adalah zinc 2 plus ialah 0.45 molar, and partial pressure of hydrogen gas is 2 atm, and concentration of H plus adalah 1.8 molar. This is kamu calculate this cell potential. This is non-standard cell potential, therefore you have to use the Nernst equation to find it out. And also dia bagi kamu SRP value untuk zinc and also hydrogen. So untuk you solve this kind of question, as usual, you need to build the half cell reaction of the anode, the cathode, and the overall cell reaction. Okay, so how can you know which one yang berada di anode dan di cathode? Tengoklah SRP value masing-masing. SRP value mana yang lagi tinggi and also close to positive value akan berada di cathode. Therefore, we can conclude here that SHA ataupun hydrogen gas ni dia akan undergoes reduction dan dia akan berada di cathode, manakala zinc akan berada di anode. So you build lah half cell reaction equation of zinc bila dia undergoes oxidation. Okay, so this is how it looks like, and also half cell reaction of hydrogen bila dia undergoes reduction. This is how it looks like. Okay, with dia orang punya respective SRP values. Okay, and lastly kita akan dapatlah overall cell reaction once the number of electrons of the half cell reaction oxidation dengan reduction yang berada di anode cathode ni dah balance. Okay, so 2 ni boleh cancel with 2. So this is your overall cell reaction equation. And after that, carilah value ataupun nilai standard cell potential by using this formula. SRP value of cathode kena minuskan dengan SRP value of the anode, and you will get this value. And next, by referring to the Nernst equation, you know that you need to find N and also Q. N is 2, Q ialah reaction quotient. Okay. Kan I told you guys earlier that this question is quite unique because dia punya Q dia unique. Previously, you always met Q concentration sahaja kan, bagi yang concentration, but this time around digabungkan sekali concentration dengan partial pressure. Because why? If you look at the overall cell, Q ni depends pada overall cell reaction equation tau. So if you look here, you can see that dekat produk kamu ada hydrogen gas dengan zinc 2 plus aqueous. Dekat reactant kamu ada H plus aqueous dengan zinc solid. Solid phase memang dah sasar, kita tak akan masukkan dalam reaction quotient. Okay. But I know that you might be a little bit confused here because as what you have learned dekat SEM 1 chapter 6, you know that kita ada QC, kita ada QP, and then kalau untuk fasa ataupun phase gas ni, kita boleh expresskan dia in terms of QC and also QP, di mana kalau untuk fasa gas, okay, sama ada dia boleh jadi, kalau QC dia boleh jadi concentration of H2, ataupun kalau let's say QP dia boleh jadi partial pressure of H2. Okay, tapi kalau untuk phase aqueous dia hanya boleh jadi concentration sahajalah. Okay, but in this case, since that dia dah bagi info kat sini, partial pressure of hydrogen gas apa, concentration of H plus apa, okay, so you masukkan, you boleh gabungkan. Since that this reaction quotient, dia tak specifykan is it QC ke or QP, okay. So as long as, if you look at the overall cell reaction, dia tak ada solid, dia tak ada pure liquid, okay. Dia ada bagi information untuk concentration, okay. Dia ada bagi information untuk partial pressure. You masukkan saja, gabungkan in one formula begini, okay. Okay, lepas tu kita tahu dekat bahagian produk we have hydrogen in gas, okay. Kalau hydrogen in gas, kalau you nak expresskan dalam bentuk Q, it's gonna be, since that dekat soalan ni dia bagi info partial pressure of hydrogen gas, therefore dia akan jadi partial pressure of hydrogen gas lah. Okay, how about zinc 2 plus? Zinc 2 plus dia bagi concentration and dia pun dah bagi info on the concentration, so tak ada masalah. And then bahagikan dengan apa yang ada kat reactant ialah H plus. H plus pun dia ada info kat sini, concentration of H plus which is 1.8 molar, so you masukkan saja H plus di bawah ni. And lastly, okay, once you have found all of the items that you need, and then you masukkan saja all of the values, okay. Oh, by the way, partial pressure of hydrogen gas ni dibagi 2 atm, sebab itulah ada nombor 2 kat sini, okay. Jangan terkejut pula. So lastly, jumpalah kamu value of your non-standard cell potential, which is positive 0.78 volt. Okay, so as long as you remember the step by steps in getting the or calculating the non-standard cell potential ni, you should be fine. Okay, so ingatlah step pertama, tentukan mana satu yang berada di cathode dengan anode. Lepas tu you build the half cell reaction equations yang berada di anode, di cathode, okay. You kena ingatlah kalau anode dia undergoes oxidation, cathode dia undergoes reduction, so you have to be careful when you want to build dia punya half cell reaction equation. Lepas tu, after you dah balance out the electrons, you can find the overall cell reaction equation, because this will be useful towards building the reaction quotient, okay. And after that, you carilah the value of the standard cell potential by using this formula, SRP value of cathode minus SRP value of anode. Lepas tu, cari item yang tertinggal lagi dekat this Nernst equation, which you need to find N. N ialah the number of valence electron in order untuk you dapatkan overall cell reaction equation ni. Lepas tu, by looking at the overall cell reaction equation and also the information given in the question, okay, so you build the reaction quotient equation, okay. And you have to make sure kalau let's say dia pure solid and pure liquid phase, you cannot includekan dia. Okay, sama ada dia aqueous atau gas phase sahaja. You boleh gabungkan macam ni. Lepas tu, you dapatlah jawapannya apa. Okay, that's the step by steps in order for you to find the non-standard cell potential by using the Nernst equation. Okay, next, how can you calculate the value of K from the Nernst equation? Okay, K ni apa? K adalah equilibrium constant. Okay, at equilibrium, actually there will be no net reaction occur. So therefore, reaction quotient will be equals to the equilibrium constant, and the non-standard cell potential Ecell will be equal to 0 volt. So how can you find K from the Nernst equation? So you masukkan saja information ni, okay, di mana dia kata Ecell 0, Q equals to K. Lepas tu dah Ecell 0, you pun susun this equation. Therefore, you know that at equilibrium, E naught cell is equal to 0.0592 over N kalikan dengan log K. Alright? Okay, contoh soalan dia akan suruh kamu calculate the equilibrium constant for this kind of following reaction. So, you need to bear in mind, you boleh relatekan Nernst equation when you want to find the equilibrium constant, because at equilibrium, the non-standard cell potential is equals to 0 volt, Q is equals to K. Therefore, kalau you masukkan ni dekat the Nernst equation yang asal, and you akan dapat this kind of arrangement to find K. Okay, so kat sini you kena cari standard cell potential. This one, as usual, we can find it from the formula E naught cathode, SRP value of cathode minuskan dengan SRP value of the anode. Okay, and then N ni ialah number of valence electron. Okay, so nak tahu N, nak tahu E naught cell, so kita kena build lah this kind of table again. Okay, so sekarang ni soalan tak bagi SRP value of silver and copper, tapi jangan risau, dalam exam biasanya dia akan bagi. So you just look at the SRP value, which one yang ada higher value will be at the cathode. Okay, ataupun yang lagi more positive will be at the cathode. Therefore, okay, kalau dah dibagi dalam soalan, sepatutnya you can see the SRP value for copper is higher compared to silver. That's why copper akan berada di cathode, silver akan berada di anode. Okay, since anode dia undergoes oxidation, so silver ni dia akan lose electron. So this is dia punya original half cell reaction equation, and this is the original half cell reaction equation untuk copper bila dia undergoes reduction, di mana dia akan gain electron, okay, dan menghasilkan copper solid. Untuk balancekan the number of electron, kita kena kalikan the half cell reaction equation of silver by 2, and therefore bila once you have balanced out the number of electron, 2 electron, okay, nanti dia akan jadi macam ni, 2 silver solid, and you will get 2 silver ion pluskan dengan 2 electron. So now you can cancel out the number of electrons yang sama, and this is the overall cell reaction equation. Okay, kat sini jangan risau, since Q equals to K, so you don't need to worry to build the reaction quotient. You just need to find this K value sahaja. So you carilah E naught cell melalui this formula, E naught cathode minus E naught anode. So you will get this value, the number of valence electron yang you boleh cancel out to proceed untuk buat overall cell reaction equation ialah sebanyak 2 electron. Okay, and equals to 2. So you ingat balik this formula to find your equilibrium constant. Therefore, you will get K is equal to 3.467 times 10 to the power of 15. Okay, next, how can you predict the spontaneity of the reaction? Okay, so to predict the spontaneity of reaction yang melibatkan the non-standard cell potential, jangan risau, dia punya, walaupun dia non-standard, sama sahaja dia punya indication dia dengan standard cell potential, di mana kalau let's say you kira Ecell you punya value you dapat positive, therefore the reaction is spontaneous. Kalau Ecell value you negative, the reaction is non-spontaneous. Okay. So for example, if we have this kind of questions, okay, dia suruh kamu refer to this cell notation and predict the spontaneity of this galvanic cell. Okay, so sekarang ni, kalau you look at this cell notation, you will know that this part belongs to the anode. Okay, this is the bridge, and then this part belongs to the cathode. Okay, so sekarang ni dia dah bagi SRP value untuk nickel and chlorine. So the one yang more positive value adalah chlorine, therefore chlorine will be at the cathode. Nickel akan berada dekat anode. Okay, so chlorine bila dia undergoes reduction, dia akan gain electron. This is how the half cell reaction of chlorine looks like. And this is how the half cell reaction of nickel looks like. Okay, with dorang punya respective SRP values. And once you have balanced the number of electrons, you can cancel out the electrons. So therefore you will get the overall cell reaction equation is nickel solid plus chlorine gas, and you will get nickel 2 plus ion aqueous plus dengan 2Cl minus aqueous ion. Okay, and then you cari dia punya inert cell melalui this formula, inert cathode minus inert anode, and you will obtain dia punya value untuk standard cell potential. And next, the number of the balanced electron here is equals to 2. How about the Q? Q pula, as usual, we will cancel out the one yang ada pure solid ataupun pure liquid phase. And if, as you can see here, Cl minus ni dalam aqueous phase, so it's gonna be concentration. This one pun gonna be concentration. Yang bahagian reactor ni, since that this is a gas, so it's gonna be partial pressure of Cl2. Tapi jangan risau, all of this information you can get it from here, where the concentration of the Ni2 plus adalah 0.02 molar, concentration of Cl minus ialah 0.1 molar, and the partial pressure of Cl2 ialah 1 atm. So you masukkan saja di dalam Nernst equation ni to find your non-standard cell potential, which you will get the positive value. So since that the E cell is positive, therefore the cell reaction is spontaneous. Kalau you dapat negative, the reaction will be non-spontaneous. Okay. Okay, so finally it's the end of the subtopic 3.2. So I've made a summary slide for the Nernst equation where you can find this is the main Nernst equation, and also we have learned just now about how to find the equilibrium constant through the Nernst equation, which it will evolve into this kind of formula, and also you can determine the spontaneity of the non-standard cell potential by using this kind of table. If you get it positive, it's going to be a spontaneous reaction. If you get it negative value, it's going to be a non-spontaneous reaction. Okay, so that's all for now. Thank you guys.